This is part two of derivatives as slope. And just go over some basic things. A secant is a line intersecting a curve through 2 points, which has a slope. And secant crosses through a circle, intersects a circle. It also is one that crosses through a curve. A tangent, on the other hand, intersects a curve at 1 point. And you will see written in math books difference quotient, which is the slope of the secant line. And this is actually the slope equation that we're used to, y2 minus y1 over x2 minus x1. And this is another form of it. Now this is called the difference quotient. This is the difference quotient because you have the difference on top and bottom, and it's a quotient. Same with this one. We went through a problem in the last slide applying this. Another way to write that down here is m, the tangent of the tangent is the first derivative. Notice this little mark right here is a prime mark. The limit as h approaches 0 of, and there it is, the difference quotient right there. So in part one, we applied that concept to x squared minus 1, and we plugged in the point 2 plus h and 2. And that took some work, but we did plug it in. As you can see here, this is what we did in class and got these numbers right here, and we ended up getting 4h plus h over h. Go back and review your notes on this. And if we plug in our 0, we get 0 over 0, which is the indeterminate form, which means we can reduce it. So we take the h out, common factor it, cancel it, and we get 4 plus h. Now we come back over and put the h equals 0 in, and we get 4. So the slope at x equals 2 here, for this parabola, the slope of the tangent line is 4. Now, all that work has been crunched into one line here, you'll see. And now what I want to do is do the same thing with this, but instead, I want to generically do x plus h and x rather than 2 plus h and 2. So I'm going to substitute these into the same problem. We'll do this kind of fast. So I blob in x plus h, and then I subtract from that the second function, f of x, which happens to be x squared minus 1. When I put all this together, I'll get over here, any place I put in h, I'm going to get 0 over 0. So I keep reducing, combining like terms. You'll notice the x squared and the minus x squared, the 1 and the negative 1, are going to add to 0. Again, if I plug in a 0, I'm going to get 0 over 0. So I common factor and reduce, and I get 2x plus h. And then I plug the 0 in again, and I get 2x. Now we have just found the general equation for slope for all points. So just like up above, I put a 2 in. I'm going to put a 2 in this general derivative or slope equation that I created using the difference quotient. So this actually means that the slope at x equals 2 is 4. So I try it again with the 1. What's the slope at x equals 1? Well, I plug it into my general slope equation. I can't do that up here. I have already set this one to only work with 2. The nice thing about this general slope equation is it gives me the general slope. So I tried a couple of them here. X equals 1, the slope is 2, and x equals negative 1, and the slope was negative 2. So now what I want to do, you to do is to go onto your desmos calculator, and we're actually going to do this on our graph. So go here in the drop-down menu and go down to here it is, calculus tangent line, and turn that on. Now the equation that they have here, we're going to replace, and once we replace it, we could put any equation we want in here. And we're going to put the one that we have, which is x squared minus 1. And let's see here if we can expand this more. All right, good. And I'm going to put another equation down here called g of x, or g of a. Let's try a. Yeah, that's going to do it. I messed up there, sorry. G of a. And it's going to tell me the slope at these different a points here. So let's see if we can get a little more room. All right. And pull our graph down a little bit. All right, good. All right, here we are. So let's go to a equals 1, which is x equals 1. We'll see the slope of the tangent line here is 2. We did 2, so I'm going to go to x is 2, or a is 2. And you'll notice the slope of this line, now you can count it, but I already put it over here on the side, it's 4. And if I want to go to negative 1, let's see if it'll let me go negative, yeah. I will get the slope to be negative 2. Now think about that general slope equation that we have for this, which is 2x, and put in negative 1 in for x, and you will get the slope right here, negative 2. Okay, so let's go back. So here's where we left off. This is the one we just did, x squared minus 1. And here was the slope, general slope equation, 2x, that we found through this long process of the derivative. We plugged in a 2 and we got 4, and we plugged in a 1 and we got 2. So what I'd like you to do is go in and experiment on the desmos calculator and see if you can do this. Create your own equation called the tangent derivative at x squared minus 1, and experiment with it and just see how that works. So this is part 2 of derivatives with the tangent line. I hope this helps you out, and I hope you experiment with the desmos calculator. Again, if you just want to take a screenshot, this screenshot kind of summarizes how to do the derivative of x plus h minus f of x on this one particular problem. Thank you.